In early September 1859, an invisible force left the surface of the Sun, and began its journey across the void. 17 hours later, it reached Earth. What followed would leave scientists struggling for explanations for more than 160 years. It was an event so powerful that it briefly turned the relationship between our planet and its star into something dangerous and unpredictable. We still do not fully understand what the Sun is capable of, and we may not be ready for the next time it decides to remind us. On the morning of September 1, 1859, Richard Carrington was alone in his private observatory in Red Hill, England. He was a meticulous and patient observer of the Sun, a man who spent years carefully recording the slow movement and changing shapes of sunspots. That morning he was sketching a particularly large and complex group of spots, when at precisely 11:18 a.m., two intensely bright points of white light suddenly appeared within the dark region. The flare was so brilliant that it stood out clearly against the already blinding surface of the Sun. Carrington watched in astonishment as the 2 points of light moved and changed shape over the course of 5 minutes, before fading away completely. He immediately noted the exact time and the appearance of the phenomenon in his records. He even called out in the hope that someone else in the observatory might witness it, but the event was already over. Carrington did not yet understand what he had seen. No one did. He had just become the first human being in history to observe a solar flare with his own eyes, and the first to leave a precise written record of it. What neither he, nor anyone else on Earth could know, was that the force released by that brief flash was already racing toward them. "17 hours after Carrington's observation, the first effects reached Earth. In the early hours of September 2nd, the night sky began to change. Across the northern hemisphere, and far further south than anyone expected, the aurora ignited. Curtains of red, green and violet light rose high into the darkness, visible not only in Canada and Scandinavia, but over the Caribbean, Central America, and even parts of South America. In the Rocky Mountains, gold miners woke in the middle of the night. The sky was so bright they believed dawn had come. Some began preparing breakfast. Birds started to sing, confused by the false light. In Cuba, people stood in the streets, staring upward in silence. In Rome and other European cities, the same strange glow filled the sky. Newspapers later described the spectacle as if the heavens themselves were on fire. The magnetic instruments in observatories across Europe and Asia swung violently off scale. Something enormous had collided with Earth's magnetic field, and the planet was responding. While the sky burned, another far stranger phenomenon was unfolding on the ground. Across Europe and North America, the telegraph network began to behave as if it had a life of its own. Operators reported sudden electric shocks from their equipment. Sparks leapt from the wires. In some stations the paper caught fire. Messages became scrambled, unreadable, or arrived as streams of meaningless symbols. Then came the most unsettling reports of all. In several places, including the line between Boston and Portland, operators discovered they could disconnect their batteries completely, and the machines continued to work. The current was coming from nowhere they could explain. It was being induced directly by the storm itself. One operator wrote to another, "Please cut off your battery entirely for 15 minutes. The reply came back, "It is now disconnected." They continued the conversation for nearly 2 hours, transmitting messages using only the power generated by the geomagnetic storm. For a brief time, human communication was carried not by electricity they had created, but by the energy of the sun itself. What Carrington witnessed was a solar flare, a sudden and powerful release of energy from the sun's atmosphere. But the real danger was not the light. It came afterwards. Along with the flare came a coronal mass ejection, a vast cloud of magnetized plasma hurled into space at tremendous speed. Traveling at more than 1,000,000 kilometers per hour, it crossed the distance from the sun to Earth in only 17 hours, far faster than most such eruptions. When this cloud struck Earth's magnetic field, it violently compressed the magnetosphere, and triggered a global geomagnetic storm of extreme intensity. Powerful electric currents were induced across the entire surface of the planet. These currents flowed through the long telegraph wires, overwhelming the systems, and in some cases, becoming their only source of power. According to modern estimates, the Carrington event reached the highest level on the geomagnetic storm scale. Some researchers believe it may have been even stronger. For the technology of 1859, it was a strange and dangerous curiosity. For the technology of today, it represents an entirely different kind of threat. The event of 1859 is still considered the most powerful solar storm in recorded history. But it is far from the strongest thing our sun is capable of. In the annual rings of ancient trees, scientists have found traces of far more destructive events. They are called Miyake events, named after the Japanese researcher who first identified these anomalies. The best known of them occurred in the years 774 and 993 of our era. But the most powerful one discovered so far took place around 12,350 years before our time. On that occasion, the amount of radioactive carbon in the atmosphere rose almost twice as high as during any other known solar event. These ancient storms were so intense that they left a clear signature in the wood of trees across the world. If something similar happened today, the consequences for modern civilization would be catastrophic. The sun has already shown us what it can do. We simply have not yet lived in an age when it could destroy almost everything we depend on. In 1859, humanity depended on the telegraph. Today, almost everything we live by rests on a far more fragile system. Imagine days, weeks, and possibly even months without the internet. Without mobile communication. Without television. Without the ability to simply open a map on your phone, send a message, or find out what is happening in the world. Powerful induced currents could damage or completely destroy large transformers in power grids. Hundreds of satellites would be at risk. GPS, mobile networks, and the global internet could stop working for extended periods. According to various estimates, the economic damage in the first year alone could reach into the trillions of dollars. But this is no longer just about money. It is about how quickly modern human beings become helpless when the things they treat as essential as air suddenly disappear. This is no longer a story about strange telegraph machines and beautiful lights in the sky. It is a question of what would remain of our ordinary lives if the sun suddenly decided to remind us of its power. The sun has not changed. It continues to do what it has done for billions of years, slowly, powerfully, and completely indifferent to what happens on the surface of one of its planets. We are the ones who have changed. We have built a civilization that for the first time in history has become directly dependent on the delicate balance between Earth and its star. In 1859, people looked up at the burning sky with a mixture of wonder and fear. Today we look at the annual rings of ancient trees and understand far more. We no longer see only a beautiful natural phenomenon. We see a warning. Today we already know how to do some things. Satellites can give us a short warning, sometimes only 15 to 40 minutes. New missions are improving the accuracy of forecasts. In some countries, protective devices are being installed on transformers, stockpiles of critical equipment are being created, and response procedures are being practiced. But overall, modern civilization still relies more on the hope that a powerful strike will not come in our lifetime than on genuine readiness for it. The sun has already shown us what it is capable of. We have simply lived through a relatively quiet period so far. And the more complex and interconnected our technological systems become, the higher the price of the next major impact. The question is no longer whether something like this will happen again. The question is whether we will recognize our vulnerability and take at least the necessary steps before it does. Thank you for watching this journey into one of the most powerful and least understood forces in our solar system. If you enjoyed this video, please hit like button, subscribe, and turn on notifications so you don't miss future episodes, and tell us in the comments, do you think modern civilization is truly prepared for the next major solar storm? In the next video, we will explore another profound enigma, what really happened 12,800 years ago. Younger Dryas. See you in the next one.